Hey guys, it's Mr. Dugal, and today we're going to talk about how you can use an equation to help you make a prediction. Before we begin, I want you to understand that you can actually use, here we have a table and obviously our graph. You can use a table and a graph to help you make a prediction too. And in this example, it's a pretty simple example. Both a table and a graph might be as effective or even maybe more simple than the equation. But in the long scheme of things, the equation is the way to go. And we're going to get into why that is. So first of all, we have an XY table here where practices are X and errors are our Y. So right now we're going to pretend like we are running a production, a play production, where the cast of characters that we have, we're charting how many errors they make. Before we don't have any practices, then we have one practice, then we have 2, 3, etc. And our question is, how many times do we need to practice in theory to be error-free? Now, a few disclaimers on this. 1, in all likelihood, when you practice anything, it won't be a linear digression, meaning that at some point the line would actually level out if you think about it. It's most likely not, it's going to be a non-linear relationship. It will be a decreasing or a negative negative non-linear relationship, but it will be non-linear all the same. For these purposes, though, we're going to pretend like it's a perfect linear relationship. What I mean by linear is that with every practice that we do, it decreases exactly the same amount of errors. So before we've had any practices, we have 71 errors. After one practice, it goes down by 8, so that we have 63 errors. And it goes down another 8, so that every time it's going down a perfect 8. Okay. If we were to set up our equation knowing that it's decreasing by 8 and knowing that we started at 71, another way to look at this is on our graph, our y-intercept is 71, and our slope we would find to be -8, based on the fact that these are our points. We could say from the change in y over the change in x would be like so. It would be 71 minus 63 equals 0 minus 1. Make sure that make sure the biggest thing when finding slope is that if I start with this coordinate, that I start with it both times. In other words, 71 comes first and then 0 comes first. If not, I'm going to flip. I also can know that this line is negative, so my slope should output as a -8. So we have 71 minus 63 is 8 over 0 minus 1 is -1. The slope is 8 over -1, or again, it's -8. So I know that my slope is -8, and I know that my y-intercept is 71. The equation for this line is y equals -8x plus 71. And basically, I can use my equation to figure out how many times I would have to practice. Because this is a linear relationship, I can figure out how many times that I need to practice so that I don't make any errors at all, so that my cast makes no errors. How many times would that be? So if we think about this, we want to say that when y is 0, x is what? So we just plug in 0 for x. Now this is a simple algebra problem where I actually solve for x. I would add 8x to each side, which gives me 8x to be 71. When I divide by 8, I find that x is 8 7/8. Now, I intentionally chose one that wouldn't divide in evenly so that we would have to think about the context, because that is most often going to be the case, that it doesn't go in exactly perfectly. And when we think about this, we think if we practice 8 times, we're still going to have a few errors. We're going to have 7 errors. We're going to have a remainder of 7. But if I practice 9 times, then I will not have any errors. So the answer to my problem would be I would need to practice 9 times. Earlier I said that you could use a table or a graph to actually do these. And to use the table would be fairly obvious. You would just keep subtracting 8 until you got to 0 errors. And with our graph, it'd be the same. You would plot it down. The problem is, with bigger numbers, with the chart, it's going to end up being a very arduous, a very long, boring method to do it that way. And with a graph, it's not always exactly precise to connect the graph over. It's very easy to make a human error. With an equation, it's really precise and it's really quick. Basically, think about it. With an equation, you're going to end up dividing rather than having to do that repeated subtraction over and over again. So the chart, the table will involve multiple steps of subtraction, whereas the equation will just involve one division problem. So that's about it. Hopefully this helps with thinking about how we can use graphs, tables, and hopefully mainly equations in our equation and slope-intercept form to help us make predictions about what will happen and help us to make data-driven decisions as we move forward. That's about it. Thanks so much for listening.